Well, I keep thinking of things to add, so let's add this. At least in the later circuits, when you get to this point, the maximum will have occurred very close to here. Now you can do this and verify that, okay? This means that the acceleration in the direction of motion has got to be negative because it's slowing down. Okay, so you have an acceleration, the tangential acceleration, right? Motion, not motion. Okay? Also, you have an acceleration perpendicular to the path, right? Which is not back in the direction of the r vector. If it was a circle, then it would be, but you have the normal component of the acceleration perpendicular to the path. Okay? Which is what changes the direction, causes the curvature. Curvature being a function of how fast you're moving and your normal acceleration. Now we'll analyze that more in detail, but analyzing it with this function pretty much covers most of the techniques that are involved in analyzing accelerations. Also, and I've said this before, but it's worth repeating because we're just doing an introduction here. This thing carries a coordinate system around with it, the coordinate system being the direction tangent to the circle and the direction normal, or tangent to the path and normal to the path. So if this is an amusement park ride, which would be a pretty boring one because pretty soon you slow down, but maybe at the beginning you break your neck. So you don't even realize you're slowing down, okay? Because you kind of have infinite acceleration at t equals 0 because of that, okay? And obviously that can't happen, so you probably start this sometime later than t equals 0 because no machine on Earth could actually accomplish this. The machine itself would break. You can't have infinite acceleration as long as the machine has mass, right? Okay? Because it would take infinite force. And nothing can withstand infinite force. Nothing with mass. Okay. Well, so you're on this ride. Well, what's your perception? Wherever you are in this circle, you're looking straight forward. Maybe you're looking off to the side, but you assume you're looking straight forward, right? Well, that means you're looking in the direction of the velocity vector. It means you're looking in the direction of this tangent vector, right? And this is usually a unit tangent vector, a unit normal vector. We'll see that later. And your velocity is changing. Your speed is changing. You're slowing down, but you're also being kept in the curve. Well, you know what happens when you drive a car around a curve. You feel like you're being tossed out, a centrifugal force, right? It's because you have a centripetal acceleration, okay? Your acceleration perpendicular to the curve is what causes you to feel like you're being thrown away from the curve, okay? And if it's great enough, you get tossed out, whatever. Okay, hope you're not going too fast when that happens. And you're not too high. Does that make sense? Go to a county fair and experience this. And I don't have stock in the county fair or anything. I like county fairs.
Is that next week?
Huh?
Is that
Yeah, it's
next
coming
week?
up. It's coming up, probably next week. I used to go every year when kids were young.
Yeah,
and
get extra
kids were
credit
young.
for
Huh?
probably gonna get extra credit for riding the rides and describing their centrifugal force acceleration.
The what?
Will we get extra credit for riding the rides?